So let's get down to business. How did we come about progesterone? By God, this is a female hormone. How in the world could it be a neuroprotectant? And I'm here to tell you that, well, I don't want to put you on the spot. I was going to ask how many people in here believe it's a female hormone? And I know all of your brains right now are saying, I should say yeah, but I'm not because I know it's a trick. It's not a trick. It's not a female hormone. Okay, it is a developmental hormone. It is very highly conserved. It is in single cellular animals, okay, or single cells. Very highly conserved. It's even in the plant kingdom. In fact, a majority of this comes from yams or the yam-like product, okay? So it's a very highly conserved entity. Why is it in the menstrual cycle of a female? That's where we found it. That's why we call it a female hormone. It actually turns out it's probably there for neuronal development during the fetus. So a lot of clues that we know now of what's going on. Harry mentioned the discovery. This is the gentleman that he was referring to, Dr. Donald Stein, 37 years ago, discovered that his animals were doing a whole lot better if they were female after a head injury. So hormonal cycling here, remember the menstrual cycle, you get estrogen peak, then you get a progesterone peak. If they become pregnant, your progesterone goes through the roof and goes very high during the third trimester. So this is the cycle that really gave Don his first clue as to what was going on and gave him the evidence. This is the first data slide that was ever generated 37 years ago in these animals. And what he showed was that here are the male animals, here are female animals, and here are female animals pregnant. And one of the things that you can see is that the female animals did better than the male animals regardless of where they were in their menstrual cycle. This was actually pro-estrus when estrogen is higher. But when the animals were made pseudo-pregnant, which is where their progesterone goes exceedingly high, there was almost no swelling in the brain after the injury. This was his epiphany. This was his moment where he goes, I got it. Because it could have been a whole lot of other things. Could have been different areas of the brains responsible for different things, a whole variety of things to look at if you were trying to figure out why your female animals were doing better than males. But being a brilliant man like he is, he looked at the low-hanging fruit, something he could, that he could modulate, and found out that indeed it was the hormonal milieu at the time of the injury that really protected these animals. So when you look at progesterone, what is it? Okay, so I said it wasn't a female hormone. It's actually one of the, very similar to the steroid and the other hormones that are made. It comes from a cholesterol organic molecule. In the mitochondria, it's then made into pregnenolone, and then you get progesterone. So this is the pathway that we look at. So one of the interesting things about progesterone is that it's the only one, not estrogen, not testosterone, not any of the others that you're familiar with, are produced and made in the brain. But progesterone is actually made in the brain by neurons and glial cells. So that should give you a clue that there's a fundamental critical importance to it. Also turns out that there are equal number of receptors for progesterone in male and females in the brain. Another phenomena that only recently has been revealed by Schumacher et al. In France. So some of the other sort of data slides, again, not to get too data deep, but the bottom line is progesterone administration. Remember the first slide I showed you was endogenous levels that he manipulated. Then he said, well, we should give it and see if it works. And indeed, when you gave it, it worked. And even more importantly, at the time, we had no idea whether males would respond to it at all, because this was, at that time, a female hormone. And it turned out males responded just as well as females. So when you look at some other things, like the higher the progesterone level, the lower the edema, the neuronal sparing in necrotic cavity, and neuronal survival. And then more importantly is behavior. So the animals, as we alluded to before, who got progesterone are almost similar to shams when they're given, after traumatic brain injury, when they're given progesterone. So Harry alluded to that over 200 papers now. I need to fix this. I think it's now 240 according to Don's count, of positive studies using progesterone in a neuroinjury model. Rather phenomenal. 4 animal species, 24 different laboratories, 22 different animal models. Okay, this is data and that's hard to refute. I can't imagine there's absolutely zero other drugs that have come to this point who have had this kind of preliminary preclinical data. Just hasn't happened that I'm aware of in traumatic brain injury. So rather phenomenal amount of data, but you might say, well, so how does this work? What does it do? Well, the beauty is that it's pleiotropic. Remember we talked about it in the NMDA channel? And all those MK801s and MDA channel antagonists didn't work. So the question is that the wrong approach? These single targeted approaches, this mechanistic approach that we have been forced into actually by NIH and others, just aren't the right way when you see that huge cascade of problems that are going on. And you know, I akin it to a cup with a bunch of holes in it, right? So if you put your finger over a single one of these holes, you're still going to get wet, the cup's still going to be empty, okay? What you need is something that's going to cover all of these holes, or at least a large proportion of these holes, to slow down this problem of a holey cup, right? So that's what progesterone does. It does many of these things. It's actually active in multiple different pathways, including reducing inflammatory cytokines, indirectly blocking the NMDA channel, working on the blood-brain barrier and reducing apoptosis. So quite a phenomenal drug, which is probably why it is so highly conserved.